Hello everyone. So today let's learn the concept of how an SQL works in an SQL engine. Let's break down this concept into mainly six components. What is an SQL engine? The key components of an SQL engine, the step-by process of how an SQL engine works, the types of SQL engine, the execution or order of an SQL query, and when this with a conclusion. So what is an SQL engine? Also commonly referred to as an SQL database engine or SQL query engine, is a software component that processes and executes SQL queries on a database management system or RDBMS. It is responsible for parsing, optimizing, and executing SQL queries to retrieve or manipulate data in a database. So, what are the components of SQL query engine? There are mainly five components. Parser, which is responsible for breaking down the SQL statement into individual tokens and parsing the tokens into a parse tree. Optimizer, which is responsible for optimizing the SQL statement, selecting the most efficient execution plan. Executor, responsible for executing the query according to the execution plan. Storage manager, which is responsible for managing the storage and retrieval of data. Cache manager, which is responsible for managing the cache which stores frequently accessed data. Now let's know the step-by-step process of how an SQL works. So, step 1, SQL statement received. Here the SQL engine receives a SQL statement from a client application, such as a query tool or an application programming interface or API. Step 2, lexical analysis. The SQL engine performs a lexical analysis of the SQL statement, breaking it down into individual tokens such as keywords, identifiers, and literals. Step 3, syntax analysis. The SQL engine performs a syntax analysis of the SQL statement, checking that it conforms to the SQL language syntax rules. This involves parsing the tokens into a parse tree. Step 4, semantic analysis. The SQL engine performs a semantic analysis of the SQL statement, checking that it is semantically correct. This involves checking that the tables, columns, and data types referenced in the statement exist and are correct. Step 5, query optimization. The SQL engine optimizes the SQL statement, selecting the most efficient execution plan. This involves analyzing the query, the data distribution, and the available indexes. Step 6, execution plan generation. The SQL engine generates an execution plan for the optimized query. This plan specifies the steps that the SQL engine will take to execute the query. Step 7, execution. The SQL engine executes the query according to the execution plan. This involves accessing the relevant data, performing any necessary calculations, and returning the results to the current application. Step 8, result processing. The SQL engine processes the results of the query, performing any necessary formatting, sorting, and aggregation. Step 9 is the final step, result return. The SQL engine returns the results of the query to the client application. Now let's know about the types of SQL engine. There are four types. Relational Database Management System or RDBMS, which is a traditional SQL engine that uses a relational database model. The second one is the Object Relational Database Management System or ORDBMS. This is an SQL engine that combines relational and object-oriented data models. The third one is the NoSQL database, which is a non-relational SQL engine that uses a variety of data models such as a key value, document, or graph. The fourth one is the NewSQL database. This engine that combines the scalability of NoSQL databases with the ACID compliance of traditional RDBMS. So now let's know the SQL query versus execution order. So we write a statement in 7 steps from 1 to 7, but the execution order is different. The execution order starts from, then where, then group by, then having, and then goes to the select, and then order by, and then limit. So we can see that the SQL statements order and the execution order is very different. So the order for SQL query statements consists of 7 steps where the select distinct statement returns the final data, and the from statement chooses and joins tables to get base data. The where component filters the base data, while the group by component aggregates the base data. Having filters the aggregated data, and order by stores the final data. Limit limits the return data to a row count. The order of execution is in a way where the from is used first to choose and join tables to get the base data, and then we use where and then group by. So we have reached the end of the module. In conclusion, we can state that the SQL query execution engine is fundamental to the performance and efficiency of database management systems. The engine ensures that the data retrieval is fast and resource efficient by parsing, optimizing, and executing SQL queries. Understanding how SQL engine works can help developers write better queries, optimize performance, and troubleshoot issues effectively. All SQL engines follow similar principles but have their own unique optimizations. Thank you, and please subscribe for more videos as such.